you probably already know some rules for divisibility. For example, think right now if you already know the rules for how to tell if a number is divisible by 2. If you don't know the rule, it is if a number ends in 0, 2, 4, 6, or 8, those are even numbers, and they're divisible by 2. Can you think of a rule for divisible by 3? And can you think of a rule for divisible by 5? That one you might know. All of the tens are divisible by 5, so they end in 0. And then also everything that ends in 5 is divisible by 0. Divisible by 3, if you didn't figure out already, has no rule. There's no nice way, because if you think about your 3s, your multiples of 3, we go through all of the digits. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. We cover all of our numbers. So all of our final digits. So there's no nice rule to tell if a number is divisible by 3, at least using the final digit. So if we come across a problem that asks us, for example, is 341 divisible by 11? The easiest way to do this is with your calculator. You just do 341 divided by 11. And if you get a whole number, that means it is divisible by 11 because 11 goes into it an even number of times. If you get a decimal, that means it is not divisible by 11. 11 does go into it. 11 goes into every number some amount of times. But when we're talking about divisibility, we're talking about whether it goes in an even number of times. We don't have any like leftover bits. So the easiest way is the calculator, but obviously we're going to do the hard way. So what we're going to do now is do this with long division. I'm so sorry if you have terrible memories of long division, but here we go. So the first thing we do is we look and see if 11 goes into 3. It certainly doesn't, too small. So we're going to expand that out and go to the next one and say, does it go into 34? And 11 does go into 34. Think quickly if you know your 11 times tables. It's a nice one, right? 11, 22, 33, 44, 55. I know that 11 goes into 34 3 times because 11 times 3 is 33. And I can't fit 44 into 34. That one's too big. So now I'm going to subtract and see what I have left over. 34 minus 33 leaves me 1. And now I'm going to go to my next place value over. It's a 1. I'm going to bring it down. And instead of this being a 1, it's going to turn in, if it was in the tens place, it's going to turn into a lovely little 11. And now I'm so lucky. I know exactly how many times 11 goes into 11 one time because 11 times 1 is 11. And then I have no leftovers. So this, in fact, was divisible by 11 because 31 times 11 made 341. We're going to take a pause just to do an extra thing on long division, and I'm so sorry, again, to everybody who doesn't like it. But here we go. We're going to do one extra way to do long division. So 341 divided by 11. We're going to do what's sometimes called the big 7. And all this means is instead of going from the left across and doing each place value as you go, you're just going to use any information you already know about 11s and see how many times they go into 341. So I might maybe only remember that 11 times 10 is 110. So I'm going to go 10 11s. I'm going to put my 10 out here. 11 times 10 makes 110. I'm going to subtract and see how much is left over, and then I'm just going to keep going. I'm just going to see how many times I can put 11 into this number until I'm left with no number left. So again, I'm going to 11 times 10. I can do it again, and I bet you know, because you already saw me solve it, that you know there's another. Ooh, but this is a nice one for me. Maybe it's not nice for you, but I recognize that 11, I know how many times 11 goes into 121. Because I just happen to remember, because I'm a math teacher, of course, that 11 times 11 is 121. 11 times 11. Oh, I changed blues. Whoops. Doesn't matter. And now I'm down to 0. Once I'm down to 0, I'm done. And what I do to find my final answer is I'm going to take all of these numbers and add them up. So I go 10 plus 10 plus 11 is 31. We already knew that. 11 times 31 is 341. So that's the big 7 style of long division. If you like it, use it. If you don't, forget I ever told you. Okay. Another really helpful skill is prime factorization. In prime factorization, we're taking a number and breaking it into its component parts. We're going to try to get it as small as possible using multiplication and division only. And anytime we have a number that is composite, meaning you could multiply two numbers to get it, and neither of those numbers is 1, we're going to try to break it up smaller and smaller and smaller until it is at, we kind of call these building blocks of numbers, the prime numbers. So 12 is a nice easy one. Let's start with it. So the first thing you're going to do is just think, how can I multiply to get 12? And there's lots of ways. 1 times 12, not very helpful. 2 times 6, 3 times 4. You can use any of those. 1 times 12 is not the most helpful. But anyway, so I'm going to use 3 times 4 because I know that 3 times 4 is 12. And now I'm going to look at 3 and say, is there any way to multiply 3 other than 1 times 3? And there is not. And so 3 is a prime number, so I can stop at 3. There's nothing else I can break that up into. But 4, I can break that up because I know that 4 is 2 times 2. So I'm going to break those up. 2 is as small as it could possibly be. So we can't make those any smaller. 2 are prime. And now I have my prime factorization of 12. It is just 2 times 2 times 3. If you remember your exponent notation, you can also write this as 2 2's times 3. We'll get to exponent notation later, though, so no stress. We're going to practice with a harder number, 84. If right now you know a nice way to multiply 84, you can use your own way. I always start with 2, like if it's even, taking 2 out because it's just simpler for me than remembering my other times tables. So 84 is the same as 2 times 42. 2's prime, so that guy's done. Phew. And now I'm going to try to break up 42. You might know a way to do that already. I'm going to use 2 again because I know 2 comes out of it. You could take other things out. You could take 3 other things. We'll see. But it's 2 times 21. You could have taken, 6 out of 42? Anyway. And then I'm going to break up 21 into 3 times 7. So now I have 2 and 2 and 3 and 7. And just to double check that that is actually my prime factorization, I can put that right in my calculator. And I will see that 2 times 2 times 3 times 7 is going to make 84.